Welcome back, guys. Today, we are going to continue to work on solving for unknowns in a word problem. Let's look at our learning target. Our learning target says, I can solve for an unknown in a story problem using an equation and a model. So today, we are going to focus on how to dissect the problem and find out what we need to know. Then we're going to work on building our equation and using our model to help us solve. Let's go ahead and look at this first one. There are 13 children in a pool. 6 are boys. The rest are girls. How many girls are in the pool? Let's think about what we know. There are 13 children in a pool. That's right. So we know that there are 13. 6 are boys. So we know that 6 are boys. The rest are girls. I don't know what that rest is, so I'm going to go ahead and box that because that's going to be what we need to know. How many girls are in the pool? So if there are 13 students, 6 of them are boys. The rest of them are girls. On your paper or your whiteboard, go ahead and try to write me an equation that might go with this problem. Hit play when you're done. Did you think about the problem? Let's go ahead and see what would make sense. I saw a couple of things, so I'm going to go ahead and address our misconception in that problem as well. A misconception is a problem that you've written down, but it doesn't quite match the things that we're looking for. So let's look at the misconception that I saw someone do. I'm going to go ahead and label this misconception. That way we know that this is a wrong way of thinking toward this problem. I saw someone say 13 plus 6 equals box. Now let's think about it. Why would this problem be a misconception? Turn and talk to a partner, and then when you're ready, hit play. I heard some great conversations going. Let's think about the problem and this misconception. If there are 13 children in the pool, can I have more than 13 students? That's right, I can, because if there's 13 in the pool, there's 13. 6 of them are boys, the rest of them are girls. So it's not asking me that there's 13 children and they added 6 more, because then I would have more than 13 students in the pool. It's asking me, out of those 13 students, if 6 of them are boys, how many have to be girls? So let's think about an equation that would go with that problem. If I had 13 students, I know that 6 of them are boys, and I'm trying to figure out how many are girls. So let's look at that equation. Can I have more than 13 students? No, because there's only 13 students in the pool. I do know that 6 of them are boys. And since I already know I can't add that 6 because that would give me more than 13, then I know that I'm going to subtract that 6. And if I subtract that 6, it's going to tell me how many are left to be girls. And one thing that I like to do when I'm solving these problems is I like to label. I knew that the whole is 13 and that there were 6 boys. And what I'm trying to figure out is how many girls are in the pool. I could think 13 minus 6 equals how many girls are there? Or I could even think about my addition sentence. If my whole minuses a part to get the other part, then my part can be added to my other part to get my whole. We know that 13 is our whole, 6 is a part, and this rest is the other part. So I can think 13 minus 6 equals how many girls? Or I can think 6 plus this equals 13. On your paper or your board, use a model and see if you can figure out how many girls are in the pool. I heard some great thinking. Let's look at some of the models that you are using. I saw someone use a number bond or a part-part whole, which is perfect for this type of problem because you have a whole and you have two parts. So let's go ahead and look at that. I saw someone use a number bond. And if I'm filling in that number bond, what is my whole? That's right, my whole is 13 because it said there were 13 children. What's the part that I know? That's right, I know that there are 6 boys. So I'm going to go ahead and put my 6 into the part that I know. But now I need to figure out what my missing part is. I'm going to use this strategy. 6 plus something equals 13. So if I had 6, I'm going to count on until I get to 13. Let's put 6 in our head. 6, 7, 8, 9, 10, 11, 12, 13. So if there were 6 boys, how many girls were there? Let's go back and count. 1, 2, 3, 4, 5, 6, 7. So there were 7 girls at the pool. 6 boys plus 7 girls equals 13. Great job. I saw someone use this strategy as well. They used 13 minus 6 equals how many girls they had. I saw someone start off with a 10 frame. We draw our box, we slice it, and then we put 4 lines down. 1, 2, 3, 4. That gives us our 10 frame. 5 on top, 5 on the bottom. How many children do I need to start with? 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So now I have 13. How many boys were in the pool? There were 6. So I'm going to take away 6. 1, 2, 3, 4, 5, and 6. So how many were left to be in the pool that were girls? 1, 2, 3, 4, 5, 6, 7. So I know that there were 7 left to be girls. Another strategy that you could have used is our number line. I went ahead and drew my number line on the paper. Now I'm going to use my number line to help me figure out how to solve this problem. I'm going to think about if I had 13 and I minused 6, how many would be there that were girls? So if I had 13 students, I'm going to start there, and I'm going to minus 6. And since I'm minusing, I'm not counting forward, I'm counting back. So let's count back 6. 1, 2, 3, 4, 5, 6. And I'm going to label my number line with minus 6. And that leaves me with 7. I can also use my number line in the other direction to help me as well. So if I used my other problem, 6 plus something equals 13, I could start at the 6, and I'm using a different color to model this. And then I'm going to count on until I get to 13. 1, 2, 3, 4, 5, 6, 7. So if I did my addition sentence, I knew I would end up with 13, and that would be plus 7. So I can either use my subtraction fact or I can use my addition fact. And I'm still going to use these same numbers to help me because addition and subtraction work together to solve our problems. All right, guys, now it's your turn. I want you to show me how to solve our next problem using one of your models and an equation. Let's look at our next problem. There are 16 popsicles in a box. 8 are cherry and the rest are grape. How many are grape? So if there's 16 popsicles, 8 of them are going to be cherry. The rest are going to be grape. Let's think about what we know in this problem. We know that there's a total of 16 popsicles. We also know 8 of them are cherry. We also know that the rest are grape. We want to know how many are grape. If there's 16 popsicles, 16, 8 are cherry, the rest are grape. Let's think about what we know. If there are 16 popsicles, that is our what? That's our whole. The part that we know is that 8 are cherry. So if my whole is 16, one of the parts is 8. I need to figure out my missing part. On your paper, let's see if you can come up with an equation and a model to solve. Hit pause, and then when you're ready, hit play. How did you do, mathematicians? Did you come up with an equation? Great. Let's go ahead and look at some of those. Now, I did see one misconception, so let's go ahead and address that misconception. We know, again, that a misconception is just a wrong way of thinking about this specific problem. So I saw the misconception of 16 plus 8 equals box. Now, why would this misconception not be right? Turn and talk to a partner, and when you're ready, hit play. I heard some great thinking. 16 plus 8 equals box. Well, I know that there's only 16 popsicles in the box. If I added the 8, would I have 16 popsicles? No, that would be more than 16. So that's why this is a misconception. We already know that 16 is how many popsicles we have, so that's our whole. And we never add a part to our whole. So now let's look at another equation that someone used. I saw someone say 16 minus 8 equals box. So let's see if this one was right. I know that 16 is my whole. I know that 8 of them are cherry, so I'm going to go ahead and put a C there for cherry. And the rest are going to be grape. So I'm going to put a G. So if I had 16, 8 of them are cherry, the rest of them are grape. Would this equation work? Yes, it would, because you're taking your whole, you're minusing one part to get to the other part. Is there an addition sentence that would also help me figure out that answer? That's right. If a whole minus a part gets the other part, then I know one part plus the other part will give me my whole. So I can think my addition or my subtraction fact to help me solve this problem. I know that these are cherry, these are grape, and when you put them together, you have 16. That's our whole. Now, let's think about some of the models that you used. One model that I saw someone use was their counting on strategy. They used 8 plus something equals 16. So let's look at that strategy. They had their 8, they drew their line, and then they counted on until they had 16. 8, 9, 10, 11, 12, 13, 14, 15, 16. If these are my cherry and these are my grape, how many grape were there? That's right, there were 8, because 8 plus 8 equals 16. That's a great way to solve this problem. Now, let's think about this type of problem. 16 minus 8 equals the answer. I saw where someone used their number line. They started at 16 and they minused how many that they knew were cherry, and there were 8. So I'm going to minus 8. 1, 2, 3, 4, 5, 6, 7, 8. And that left them with 8, because 16 minus 8 equals 8. I saw someone else use their part-part whole to help them. So if I have my part-part whole, what is the whole in my problem? That's right, it's 16. What is the part that you know? That's right, you knew that there were 8 that were cherry. And I'm going to label that because that's something important to do when you're showing this work. I know that these are going to be how many are grape. So 8, 9, 10, 11, 12, 13, 14, 15, 16. And if I count those up, I know that my answer is 8. So again, 8 plus 8 equals 16. Or I could think 16 minus 8 leaves me with 8. Either way, if you use addition or subtraction, your answer will be the same. What changes is the order of where you put your missing box. Your numbers stay the same because they're a fact family and they are related to each other. You can subtract your whole and your part, or you can add your 2 parts together to get your whole. Great thinking today. You guys did a wonderful job. We're going to continue this work for the rest of the week. I hope you do really well and practice coming up with your own problems. I'll see you next time. Great job on your learning target of finding an equation and a model to help you solve for the unknown. See you next time.